Okay, so what we're looking at here then is, again, the box that I asked you to write down yesterday for your notes. You can use it on the test. It's on the bottom of page 594 here. And I need to talk about what this actually means. So what we're looking at is we're looking at rational functions, okay? And they're basically, with this p of x over q of x right here, what that is, that means just the polynomial in the numerator divided by the polynomial in the denominator. And we're try to find horizontal asymptotes. And what a horizontal asymptote is a horizontal asymptote is a horizontal line that the graph is going to approach and get closer and closer and closer to, but never touch. So that's what we're trying to deal with in this box. This is about finding the horizontal asymptotes of the graph. So then what it says is, well, first of all, it talks about the degree of p. Well, that's the degree of the numerator. And then it talks about the degree of q. Well, that's the degree of the denominator. And so the degree, again, that is the highest power, okay, or the largest exponent, or greatest exponent, I should say. All right? So if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. Okay? And then if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is the line y equals 0. Well, that's a horizontal line at y equals 0, so that's the same thing as the x-axis. And then the third case is if the degrees are equal. So the degree of the numerator is equal to the degree of the denominator. Then what you do to find the horizontal asymptote is it's going to be y equals, and it says the leading coefficient of p divided by the leading coefficient of q. Well, that means the number out in front of the highest power term in the numerator divided by the number out in front of the highest power term in the denominator. So that will be that y value, whatever that fraction is, that will be your horizontal asymptote. All right, so let's move on and look at some of these examples. And for these, I might write them down and actually just write right on a blank sheet here. But if you want to see where they're at, they're on the next page. So I think I'm just going to do the three examples that you see right here. So example 4, A, B, and C. But again, I'm going to write these functions down and I'm going to work them out. I think I'm going to need more room than what I've got in the margin here. So the first one, let me write that one down. Actually, I'll write all three of them down right now. So we got y equals x squared plus x minus 6 over x. And then we've got y equals x minus 1 over x squared. And then we've got y equals 2x squared minus 2 over x squared minus 4. Okay. So then let me go to a blank page here then. All right, so let me write down this first one. I'm going to go back for 1 second. I want to make sure I read the directions on what we're supposed to do. Hold on, I got to flip through these pages again here real quick. Where are we at? We are right there. So what are the directions? We got a zeros and asymptotes and then graph, okay. So we need zeros, asymptotes, graph. Okay, so the three things we got to do is we got to identify the zeros, we got to identify the vertical and horizontal asymptotes, and then we've got to make a sketch of a graph of the function. All right, so let me go back to that blank page again. And so our first one we're going to do, this first example, what we have is we have y equals, actually let me get a little bit, zoom in a little more. So we've got y equals x squared plus x minus 6 over x. And we're going to try to graph this function. So first of all, what's the degree of the numerator? What's the largest or greatest exponent you see there? What's the highest power you guys see there in the numerator? Yeah, what do you got? Yeah, it's a 2. Yeah, so the degree of the numerator is 2. And then the denominator, all you have is x. Well, that's x to the first power, right? So that degree of the denominator is 1. So the degree of the numerator is 2, the degree of the denominator is 1. Now you go back and you look at that box that I had you write down off of page 594. And that's the first case, right? And if the degree of the numerator was greater than the degree of the denominator, then there is no horizontal asymptote. All right? There's none. So that's what we're going to write down here then. We're going to write for horizontal asymptote, we are going to write none. So we don't have to worry about that. The next thing we're going to do is let's do the vertical asymptotes. So if we want the vertical asymptotes, well, we did this yesterday, right? So what do we do to find the vertical asymptotes? Do we set the top equal to 0 or the bottom equal to 0? We're either going to set the numerator equal to 0 or the denominator equal to 0. Which one? Come on, guys, you got a 50-50 chance here. Say it again? Yeah, the denominator. Yeah, you just set the denominator equal to 0. Well, this one's pretty simple. The denominator is just x. So we're going to say x equals 0. Well, that's already done, right? That is our vertical asymptote. So x equals 0, that is a vertical line. It's the y-axis. All right. The other thing they asked us to find was the zeros. So we also need the zeros. And the zeros, remember, those are the same thing as the x-intercepts. So what do we set equal to 0, the top or the bottom? Carter, what's that? Well, we just did the bottom. Yeah, it's the top. Yeah, we set. So all you got to do, don't overcomplicate this. All you got to do to find the vertical asymptote is set the denominator equal to 0. And all you got to do to find the zeros or the x-intercepts is set the numerator equal to 0. That's all. So we're going to set the numerator equal to 0. So we got x squared plus x minus 6 equals 0. We got to be able to factor these things, right? That's why we did all that review of the first week. So in this one, we need two numbers that multiply to -6, where the same two numbers add to, that would be +1 right here, right? So what do we got? What two numbers multiply to -6 and the same two numbers add to +1? Excellent. So +3 and -2. So if we multiply those together, they multiply to -6, but if we add these together, we get the +1 in the middle term there. Okay, so then we got to set each of these factors equal to 0. I think I did this yesterday. So we got to set x plus 3 equal to 0. And we got to set x minus 2 equal to 0. Solve each of those, we're going to get x equals -3. And this one we're going to get x equals +2 after we add 2 on both sides. So there we go. Those are our x-intercepts. And I think that's all we got to do so far for this one then. So we're going to go ahead and try to graph it. So I don't know if I think I got some room over here. So let's try to make a graph. So here's our graph. That's not very straight. Let me try that again. That'll work. So here's our graph. I'll label all this stuff on the first one. So that's x, this is y, and there we go. Now we got to put the stuff on there that we just, I forgot to move my mouse again. Hold on. There we go. So I just made an x and y axis. And then we found that there was no horizontal asymptote, so we don't got to worry about that. And then we found the vertical asymptote was at x equals 0. which is the same thing as the y-axis. So this right here, that's the same thing as the y-axis. So we're going to put an asymptote along the y-axis here like this. Okay? And then we also had two zeros or two x-intercepts. And they're right over here. That was -3 and +2, right? Right here. So those are the two x values where the graph crosses the x-axis. So we got -3. So let's see here. So -3, there's a point right there, and +2. So there's a point right there. All right. Now at this point, after we get the graphing calculator stuff going, you might want to graph it on your graphing calculator. You have that information for sure, and then you could look at the calculator to pick up what the graph looks like. But I'm actually going to do this by hand and show you where the graph comes from and why it looks like it looks. So what we need to do then is we need to pick a number close to the vertical asymptote on each side. Well, actually on this one we could just do one side. I was going to say one other thing, I can't remember what it was. Oh, so basically what we're looking for is we know that this thing either looks like, I'll just sketch it over here real quick. We know it looks like it either goes up to the left of the asymptote and down to the right, or it's going to look like it's going to go down to the left of the asymptote and up to the right of it. So it's got to look like either one of those two cases right there. I'm going to erase those out of there because those look terrible, but that's the idea. We're just trying to figure out which one of those it is. Okay, let's go back to this again. All right, so let's pick a number. I don't know, let's pick a number. I don't know, I'll pick a number just to the left of that vertical asymptote. So I'm going to pick maybe like right here. I'm going to pick a -0.5. All right, and what I want to do then is plug that into the original function. All right, so I can't see the original, I have the original function written down here, so I'll just plug it in for you guys so you can see what it looked like. So let me shrink this over here a little bit. So what we got is we have got y equals, I need to put a -0.5 in, so I'm going to do a -0.5, hold on a second. I'm going to put in a -0.5 squared plus a -0.5 minus 6 all over x, which is -0.5. All right. And then you guys can type that into your calculator. So basically what I'm doing here is I'm like making a little, it's like I'm making a table here. It's like I've got, here's x, here's y. I picked a x value of -0.5, and we're trying to find the y value. Now, if you're going to put that all in your calculator all at once, you're going to need an extra set of parentheses around it right there, or it's going to get messed up. So let me do that. So I'm going to go... You guys have the calculators too, so you got a negative. By the way, when you're squaring a negative number on these calculators also, you make sure you put it in parentheses or it'll give you the wrong answer. So I'm going to put in parentheses, I'm going to put -0.5 and then square it. And then plus -0.5. And then minus 6. So the answer to that numerator is -6.25. And then I'm dividing by -0.5. So a negative divided by a negative is going to be a positive. And if you divide by 1/2, that's the same thing as multiplying by 2. So you should get 12, or 12.5, I should say. So we get 12.5. So 12, oops, other color. So 12.5 is my y value. I don't know if I can, let's see how much room I got up there. Can I get that high on this graph? And go a little bit higher, I guess. So let me do this. I don't have too much room up there, but we got to get up to 12.5. So let's see. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, it's going to be way up there. I might have to get this stuff out of the way real quick. Hold on. I'll just redraw that for you guys. What was that? X equals 0? With a little arrow going over here, right? Okay. So where was I at? Did I get to up to 12 or did I go to 13? I can't remember. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I need 12 and a half, right? So this would be 13 up here. So basically my point is at the point negative a half, positive 12 and a half. So that's left half a unit and up 12 and a half units, which is going to put me right up here. All right. So that's my point. Negative 0.5, comma, 12 and a half. Now, can you see which one of those two cases I'm going to have then? I know my graph has to go through this x-intercept right here, that 0, right? Well, I don't have a point down here at negative a half, so it's not. So that means that curve is not curving down this way. It's got to be going. It's got to be going up like this. It's got to be going something like this. Okay, and it's approaching that vertical asymptote. Well, then from what we know about the behavior of those asymptotes, that means on the other side, it's got to be going down as it approaches the vertical asymptote. So the other side's going to look something like this. And there you go. That's our first example. We got 4 more to go. You guys good with that one? Yeah. The negative 0.5? I needed to test, I knew here, let me sketch this for you real quick. I knew that my graph was either going to go up like that and down like that, or it was going to go down like this and up like that, okay? So then I just needed to pick one x value that's close to that vertical asymptote. So I needed something close, that red dotted line right here. This is my vertical asymptote, right? So I needed something close to that, an x value close to that red dotted vertical line. So since that red dotted vertical asymptote was at x equals 0, I just picked something just to the left of 0, which is negative a half. You could have used positive a half too. If you would have used positive a half, it's John, right? John, if I would have picked positive a half, look up at the screen. If I would have picked positive a half, you would have got a point down here somewhere. And then that would have told you that it had to go this way, right? So that's what you're doing. All right, let's do another one. So the second one we got to do, this one is, I wrote it down. This one is y equals, x minus 1 over x squared. So then we're going to do the same steps again. So first thing is, what is the degree of the numerator, you guys? What's the largest exponent? Good, it's 1. Because that is x to the first power right there, right? And then the degree of what's the degree of the denominator? Yep, I got 2 fingers held up, that's 2. So now you got to go back and look at that thing I had you write down in that box on page 594. It said if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0, or the x-axis. So that's what we're going to write down. We're going to write down the horizontal asymptote is y equals 0, which I'll make a note. That is the same thing as the x-axis. Okay? Oh, I lost my screen again. I keep forgetting to move my mouse. Hold on. Oh, I got it back. Good. I moved the mouse and got it back that time. All right. So then the next thing we did is we did the vertical asymptote, right? So to get the vertical asymptote, what do I set equal to 0, the top or the bottom? Which one, guys? Set the top? Do I set the numerator equal to 0 or the denominator equal to 0? Come on, there's a 50-50 chance here. I just did it on the last one. What's that? Yeah, set the denominator equal to 0. So we're going to set x squared equal to 0. Well, then we got to solve for x. This one's kind of silly. Obviously, the answer is 0, right? X equals 0. Now, if you actually wanted to show that, if you want to solve for x, you would have to take the square root of the left side, and you would have to set that equal to the square root of the right side. Technically, when you take the square root of both sides, you have to put a plus or minus here on the right-hand side. But the square root of 0 is 0, and 0 is neither positive or negative, so you just get x equals 0. All right, so you get x equals 0, that's your vertical asymptote. And of course, that's the same thing as the y-axis, right? I just said that on the last one. X equals 0 is the y-axis. Okay, and then we got to do the zeros, or the x-intercepts. So we need the zeros, which is the same thing as the x-intercepts. Now, luckily, when you guys get the test is more like they have you do one part. Like they'll ask you, what's the horizontal asymptote? What's the vertical asymptote? What are the zeros? There's not much on the test where you have to do everything all at once like this, but... Okay, so zeros are the x-intercepts. So what do I set equal to 0, the top or the bottom? Do I set the numerator equal to 0 or the bottom or the denominator equal to 0? I got a finger pointing up here, so it's the top. Okay, all right, I got that. Good, it wasn't the middle finger, but it's okay. So we got x minus 1 equals 0. So we set the top equal to 0. And we solve that, we add 1 on both sides, and we get x equals 1. So that's everything that we need to plot now onto our picture then. All right, so we got a horizontal asymptote as the x-axis, a vertical asymptote as the y-axis, and then we have one place where the graph crosses the x-axis, and that is at x equals 1. So let's see if we can sketch all this stuff then. I'm unable to slide around here. What's going on? Oh, I can get over here like this. That'll work. All right, we'll do this. All right, so let's draw this thing. All right, and let's see, what was all that stuff again? I said we had a horizontal asymptote along the x-axis, right? Actually, let me get this up to like there. So there's our horizontal asymptote. And then our vertical asymptote was x equals 0, which was the y-axis. So we have another asymptote here. That. And then we had, what was it, x equals 1? That was our only x-intercept, right? So at 1, we'll put 1 right here. Oops. So at 1, we had our only 0, our only x-intercept was right there. Okay, so then the only thing we need to do to finish this graph then is we need to pick a x value close to the vertical asymptote. So on this one, maybe I'll pick a positive 0.5. How's that? So right in here. Now you could pick 0.1, you know, if you want. You could pick 1/10. That would be really close to the vertical asymptote. But I'm just going to use a positive half. All right. So then what I'm doing here again is I'm making a little chart. I'm just saying, okay, x is a half. What's the y value? So I got to plug 1/2 into the original function. And you guys can't see it up there on the board anymore. But I will write it down. So it's going to be y equals, it was x minus 1, so it's going to be 1/2 minus 1 all over 1/2 squared. And again, if you're putting this in the calculator, you want to make sure you put that numerator in parentheses like that. So then what do we got here? So we got 1/2, take away 1, that would be a negative half, right? So a negative 0.5, whoops. So we got a negative 0.5 divided by our denominator, which is 0.5 squared, or 1/2 squared. Well, 1/2 squared is what? That's 1/4, right? So then dividing by 1/4 is the same thing as multiplying by 4. So we should get negative 2. So we got negative 2. So negative 2 is my y value when x is 1/2. So this is a negative 2 right here. So that's the point I got to plot. So 1/2 and negative 2. So here's negative 1, negative 2. So there's negative 2 right there. So my point is going to be at 1/2 comma negative 2 is a half a unit to the right and 2 units down. So that's right there. And do you guys see that that's going to be enough to tell me what that graph looks like? Because I didn't get a point up here, right? Like if I got a point up here, then I would know that it goes this way. All right? Like that. But I did not get a point up there. I got a point down here instead, which means it has to look like this. Okay? Now, one other thing I'll tell you is that the horizontal asymptote, that is what the graph approaches way out here to the right. Okay? So when the x's get really big and positive, that's the value, the horizontal asymptote of y equals 0. That's what the graph is approaching when the x values get huge. Also over here, way to the left, when the x values get very, very negative, the graph needs to approach the horizontal asymptote of y equals 0. So that means that this thing is not going to continue on up like this. It's going to have to come back down and approach that horizontal asymptote like that. Horizontal asymptotes, that describes the end behavior of the graph. That's when the x's get very big or very negative. All right, well, what's the other part of the graph look like? Well, we could test another point if we want to. But first of all, we know that this graph does not cross the x-axis over here anywhere, right? So on the negative x-axis, it never crosses the x-axis. Well, that means that if I know the other side of it, remember what we're doing here is if you got, let me sketch this for you again. If you got a vertical asymptote, if this side is going down like that, right? That's what we have. Then the other side's got to be going up like that, right? And since I cannot cross, I don't have an x-intercept over here. I don't have a 0 over here on the negative x-axis. I can't cross the axis and go up like that, because then I'd have a x-intercept somewhere over here. So that means it has to go like this. All right. So basically it has to satisfy this idea right here that I circled, but it can't cross the x-axis because that's a horizontal asymptote. Well, not because it's, I shouldn't say that. It can't cross the x-axis because we did not get an x-intercept over here. All right, so that's our second one. We got to go to the third one. So we got what? We got 3 more to go. So let's try this one. You guys good with that one? So let me go to a new page. So here's our third one of these. The last 2 will go quick, at least compared to this. So this one is y equals 2x squared minus 2 over x squared minus 4. Well, I don't know why I got that y floating up like that. There you go. Okay? So now, again, we're going to do the horizontal asymptote first. So in order to do, I'll write this one here. So horizontal asymptote. Well, you guys tell me, what's the degree of the numerator? What's the highest or greatest exponent you see? Come on, I try to ask you guys the easy questions. Oh, I got 2 fingers again. All right, that's good. And then what about in the denominator? What's the degree of the denominator? What's the highest exponent you see? Yep. So again, I've got, so I got Dylan answering me with his fingers. So this one is also degree 2. So the degree of the numerator is 2, the degree of the denominator is 2. So if you look at your little chart there from page 594, it says that the degrees of the numerator and denominator are equal. Then the horizontal asymptote is y equals the ratio of the leading coefficients. So what that means is your horizontal asymptote is going to be y equals, it's going to be the number out in front of the highest power term in the numerator. What is that? What's the number out in front of the highest power term in the numerator? Good. I got 2 fingers over there too. That's Tyler, right? Okay. Yeah, so it's a 2, right? You guys can see that. The number out in front, that's called the leading coefficient. It's the number out in front of the highest power term is a 2. So we're going to have a 2 divided by, and then I'll speed it up here, the number out in front of the highest power term in the denominator, that is a 1 right there, right? So that's going to be a 1. Well, that means y equals 2 is our horizontal asymptote. All right, next thing we got to do vertical asymptote still. You don't really have to do these in any particular order. So the vertical asymptote for this one, what do I set equal to 0? Numerator or denominator? Good, denominator. So we're going to set x squared minus 4 equal to 0. I'm going to move my mouse here so this thing doesn't turn off on me again. There we go. There's a couple different ways you can solve that. You might notice that you could factor this. Don't write this down if you don't want to. You could factor that into x plus 2 times x minus 2 equal to 0. Then you could set each of those factors equal to 0, and you'd get 2 and negative 2. X equals positive 2, x equals negative 2. That's one way to go. Some people like to do it this way instead. They like to go, well, I'll add 4 on both sides, and that'll give me x squared equals 4. And then I want to solve for x, so how do I get rid of the squared there? Good, yeah, square root it. So we're going to square root the left side, and we're going to square root the right side. But whenever we do that, whenever we take the even indexed root of both sides, so if we take the square root of both sides, or the 4th root of both sides, or the 6th root of both sides, we always have to remember to put that plus or minus in there, because we're going to get 2 solutions. So that gives us x equals, well, positive square root of 4 would be 2, right? And we'd also get x equals the negative of the square root of 4, which would be negative 2. So those are our 2 vertical asymptotes. And then the last thing we got to do is we got to find the zeros. So for the zeros, that's the same thing as the x-intercept, right? So what do I set equal to 0? The numerator or denominator? Come on, guys, this is not that tough. I mean, some of this is messy, okay? But just saying, what do you set equal to 0? That is not a tough question. Top or bottom? Come on, you guys got a test coming up on this stuff next week. What's that? The bottom is the vertical asymptote. If you look at it right there, it shows you that I just set the bottom right here. I just set the bottom equal to 0 right there. So if I'm going to do the zeros, I got to set what equal to 0 then? The top, yeah, the numerator. You guys got to get that part straight. That's kind of the easy part. Putting it all together at the end is the hard part. So we got to set the numerator equal to 0. So we're going to set 2x squared, or 2x squared minus 2 equal to 0. Now, we could actually solve this one by factoring it. You know what I mean? We could pull out a 2, and then we'd have, don't do this, we'd have x squared minus 1. And then the x squared minus 1 would break down into x plus 1 times x minus 1. And then we'd set all the factors equal to 0. So we could do that. But I think this one I'm going to go the other way. So I'm going to solve for x by adding 2 to both sides. That gives me 2x squared equals 2. These cancel out, make 0. Then I divide both sides by whatever number's in front of that variable. Those cancel out, make a 1. So then I get x squared equals 1. But then I got to remember that I got to take the square root of both sides. I take the square root of the left side and set it equal to plus or minus the square root of the right side. The square root of 1 is 1. So I get positive square root of 1 is 1. And I get negative of the square root of 1, which would be negative 1. All right, so now we got to like put these all on a grid here. So what do we got? We got a horizontal asymptote at y equals 2. We got vertical asymptotes at x equals 2 and negative 2. And we got x-intercepts at 1 and negative 1. So let's try to draw this thing. So here we go. So I need a y-axis and an x-axis. That looks pretty good. And then I need, now I got to remember all that stuff now. At y equals 2, I had a horizontal asymptote, right? So there's that. And then at x equals 2, and at x equals negative 2, I had vertical asymptotes, right? At least I think that's what I had. So that looks like this. And like this. So you can see this one's a little bit weird compared to the other ones we had. Let me move my mouse again so this doesn't turn off. And then I had x-intercepts at 1 and negative 1. So I know my graph goes through this point right here at x equals 1 and through this point right here at x equals negative 1. So that's 1, that's negative 1. All right, this was 2 and negative 2. This was 2. Is that fun or what? Now we got to figure out what this graph looks like. Now what we did before is we made a little chart. We picked values close to the vertical asymptotes, right? So we got a couple vertical asymptotes that we got to contend with here. So let's see, what could we do here? I'm trying to think of what would work well. Well, let's pick something, I don't know. Let's pick something close to this one right here. Right there. So let's go, that's at 2, so let's go like 1.75 or something like that. All right, so what we're doing is we're making a little table here again. X and Y. We just picked 1.75 as our X value. Well, I gotta get a finer point going on this thing. 1.75. All right, so we got to plug that into our original function. All right, so here we go. So we're going to go y equals, our original function was 2 times the x squared, and then minus 2 all over the x squared minus 4. And let me fix that because that looks weird like that. Okay, so I'm going to put this in my calculator. So I'm going to do 1.75 squared. And then I'm going to multiply that by 2. And then I'm going to subtract 2. So for my numerator, I get 4 1/8. And then I'm going to divide that by, remember, if you're putting this in the calculator all at once, you're going to need some parentheses around that whole numerator and that whole denominator. So I'm going to divide that by 1.75 squared. Oops, I hit the wrong power. Hold on. No, I screwed it up again. Hold on. Delete. Delete. No, hold on. I got to start all over. I screwed it up. I got 4.125 divided by 1.75 squared. I hit the wrong button. And then minus 4. Nope, I screwed it up again. I don't know what's wrong with me right now. Hold on. I keep hitting the wrong buttons. So parentheses 1.75 squared minus 4. There. I did not mess it up that time. I get negative 4.4. So that is a negative 4.4. So negative 4.4 is going to be down here. There's negative 1, negative 2, negative 3, negative 4, negative 5. So with an x value of 1.75 here, I'm down here, all right, negative 4.4. So that gives me a point right there and come down to negative 4.4. So like down here. All right, so I have that point right there. So again, just to label this so you can see what I'm doing, that's the point 1.75 comma 4.4. Now another nice point to grab on this one right here would be the y-intercept. The y-intercept, all you got to do is plug in x equals 0, right? If you're on the y-axis, let me write this down. If you want the y-intercept, that's the place where the graph hits the y-axis. That means the x-coordinate is 0. So all you got to do is plug 0 into the original function. So that would give you y equals 2 times 0 squared minus 2 all over 0 squared minus 4. So if you look at that really carefully there, 2 times 0 squared is 0, and 0 squared is 0, so all we have is negative 2 over negative 4. So negative 2 over negative 4, which is 1/2. So that's a nice point to know, because that right there, y equals 1/2, that is the y-intercept. That's the y value where the graph hits the y-axis. So this graph is going to hit the y-axis right here at y equals 1/2. All right, well now I'm getting the idea what's going on with this thing. Let me come over here, and I'm going to plug in, let's go right here. I'm going to go just to the right of that. Again, what I'm doing here is I'm picking x values that are really close to the vertical asymptotes. So I'm going to put in a negative 1.75. So I'm going to add that to my table here. So negative 1.75. And then if I do that, it's pretty much what I did with the first one, right? All I got to do is put a negative right here and a negative right there. If you can see that, I did that really tiny. So what I did is I put in, it's the same calculation. I put in negative 1.75 into my original function. So all I did was change that 1.75 to a negative and this 1.75 to a negative. Well, when I square a number that's negative, it still comes out positive, right? If you do negative 1.75 squared, that's the same thing as positive 1.75 squared. Well, guess what? That means I'm still going to get negative 4.4, right? So I'm still going to get negative 4.4 right here. Which means now I have another point on my graph, which is right, I got to go down negative 4.4, so I'm down here. All right, so let me draw that point in. So that point is going to be right, like right there. So again, that is the point negative, or I should say 1.75 to the left. And, oh, I forgot my negative sign over here. Sorry about that. When I labeled this one, this is supposed to have a negative on it, right? And then down 4.4. Now, do you see what my graph is doing? Hopefully you can see it now. My graph is doing this right here. It is going it's going like this. All right. Now I got to figure out what the rest of my graph is doing. All right, so then I'm going to pick a point just to the right of my vertical asymptote. So I'm going to put in maybe like right here. Let's put in like, I don't know, let's just put in like 2.5 or something like that. So I'm going to put 2.5 into my original function. So I'm going to have y equals, hold on. I'm going to have y equals 2 times 2.5 squared minus 2 all over 2.5 squared minus 4. And if I'm going to put this all in the calculator at once, remember I'm going to put some other parentheses around it like that. So hang on, we're almost done. I promise the last two will be easier. Okay, so we need that. So I'm adding to my little chart here again. So now I'm doing 2.5. It doesn't look like 2.5. There, okay. So let me put that in my calculator real quick. So I'm going to do 2.5 squared. And then I'm going to multiply that by 2. And then I'm going to subtract 2. That gives me 10.5 for my numerator. And then I'm going to divide that by my denominator. In parentheses, I'm going to have 2.5 squared minus 4. And I get 4 2/3. So I get about 4.7. Okay, so this equals 4.7. All right, well, 4.7, that is up here. I got 1, 2, 3, 4, 5. So that means when I go 2.5 to the right, so I got to go 2.5 to the right, 4.7 up. Oh, I lost my screen again. There you go. So I'm going to go 2.5 to the right, 4.7 up. So that's going to put me, that's going to give me a point 2.5 to the right and 4.7 up. So I'm up, oops. So I'm up here somewhere. Well, guess what? If I put in a negative 2.5, so if I extend my chart here a little bit. So if I put in a negative 2.5, I'm going to get the same thing, aren't I? So a negative 2.5, I'm still going to get 4.7. Because if I put a negative into there and I square it, and if I put a negative in there and square it, it's not going to change anything, right? Because 2.5 squared is the same thing as negative 2.5 squared, both in the numerator and denominator. So I'm still going to get 4.7. So that means when I put in negative 2.5, that's going to put me over here. Like I said, bear with me, we're almost done. So I'm putting in negative 2.5. I get a y value of 4.7, which is going to put me right up here. Okay? Well, I know I don't have any other x-intercepts. So I know that my graph is not going to come down here and cross the x-axis. And in fact, it's not going to cross this horizontal asymptote right here. So that means my graph is going to look like that. Same thing over here. I don't have any more x-intercepts over here. So I know my graph is not going to cross the x-axis over here. And it's not going to cross that horizontal asymptote either. So that means the other part of my graph is going to look like this. And there you go. That was a lot of work, but that's the graph. Again, now, what I'm going to expect you guys to be able to do, if I re-summarize this really quickly, is I'm going to expect you guys to just you're just going to set the denominator equal to 0, find the vertical asymptotes, set the numerator equal to 0, find the x-intercepts, and then use that chart to find the horizontal asymptote. Once you do those things, you're going to plot those points. So you're going to plot these 2 zeros, and you're going to draw these 3 asymptotes, 2 vertical asymptotes and 1 horizontal asymptote. And then I'm going to show you how to just bring it up on the graphing calculator. And for you guys that are, I'll talk to the kids at home that are remote, you're going to bring that up on one of those calculators that's in yesterday's video that you could use for your phone or for your PC, okay? And then you'll be able to draw these sections of the curve in the correct spot. But I at least wanted to go through it like that with you guys so you could see why the graph is actually doing that. But let's go to the last 2 now, because the last 2 will not be that bad. So let's see if we can wrap this up pretty quick. So the last 2, I'm going to go back to the book. So again, I got to turn to the page we were on. So we're on 8.4, and we're going to wrap up the last 2 examples. And let's see. Actually, do I have room? Let's see if I got room on here to do these. I think so. I think I can do these on here. So the last 2 examples, I want to do that, check it out number 5 right there. This one. So what we're going to do is our function on this one is going to be y equals x squared plus x minus 6 over x minus 2. And what this one says is it says in the directions that they want us to find, well, let's see what the directions do say. They want us to identify any holes in the graph. So the directions right here say identify any holes in the graph and then graph it. All right? Now we haven't done this yet. We haven't talked about what a hole is. So let me sketch you that. A hole is like when the graph is going along and there's one point missing and then the graph continues. That's a hole. So we're going to try to identify those, okay? So how you do that is what I would do with this one. The first thing I would do with this one is I would factor the numerator. So we're going to factor the numerator. So we need 2 numbers that multiply to -6, where the same 2 numbers add to +1. So what would that be? Yeah. +3, -2. Excellent. So +3, -2. Now, do you guys notice anything canceling out? What would cancel out? So look at that expression now. What would cancel out? Carter, you got it? Well, the x minus 2 and the x minus 2, that whole quantity. So normally, now listen to this part. This is the part you got to get straight. Normally, if this doesn't cancel out, you'd set that denominator equal to 0, and that would tell you the vertical asymptote, right? You know right now, what value can you not put in here? What would cause division by 0? What can you not put in there for x? 2. Correct. That's Dylan, right? All right, thank you, Dylan. So yeah, you can't put 2 in there, because if you put 2 in, you'd have 2 minus 2. You can't divide by 0, so that's going to make some kind of discontinuity in the graph, okay? Well, if this thing doesn't cancel out, we would set that denominator equal to 0, and that would tell us the vertical asymptote. But instead, on this one, this whole quantity cancels out that whole quantity. Well, then if it cancels out like that, if that factor x minus 2 cancels out on the bottom, then it's not a vertical asymptote anymore, it's a hole. So if you set x minus 2 equal to 0, you get x equals 2, and that means there's going to be a hole at x equals 2. All right, that's what that tells you when that thing cancels out. So we got a hole at x equals 2. And now look at what that function simplifies to. So these canceled out right here and made a 1, right? So this function is now simplified to just y equals x plus 3. Do you guys see that? So this function is now y equals x plus 3. What kind of graph is that? That should look familiar to you guys, right? That's like y equals mx plus b, right? So that means my y-intercept here is 3. And my slope is 1 over 1. So I should be able to sketch this thing right away. So when this stuff canceled out, it left me with a much simpler function, just x plus 3. So if I go to graph that, I think we can draw this with a quick sketch. Like I said, this is going to go a lot faster than the other ones did. So we're going to draw a quick sketch here. X plus 3. The y-intercept is 3, positive 3. So I'm going to put a dot on the y-axis at positive 3. And then my slope here, the top number tells me if I go up or down. Since it's positive, I go up. And the bottom number tells me how far I go to the right. So I got to go up 1, right 1. From this point, from my y-intercept. So if I go up 1, right 1, that gives me a point right here. So that means my graph actually looks like a straight line. It looks like this. But with one exception. It's supposed to have a hole at x equals 2. So if you go to x equals 2, which would be right here. So if you go to x equals 2, and you come up here and hit the graph, right there, there is going to be a hole. Not that big of a hole. There's going to be a hole like this. So there's a little hole in the graph. Okay? That point is missing. And that'll show up on your graphing calculator sometimes, and sometimes it won't. Let's do the last one. So for the last one, let's just take this function we have and flip it over. Let's do the reciprocal of that and see what this will look like. So let me write this down real quick. So we're going to have, get my mouse over here. We're going to have x minus 2 over x squared plus x minus 6. So let's go over on the other side and do this. So now my function is going to be y equals, what did I say it was, x minus 2 over x squared plus x minus 6. And what we're going to do again to look for the holes is we're going to factor. So we're going to go y equals x minus 2. Well, we already factored that on the previous one, right? That same polynomial that's in the denominator. That factored into x plus 3 and x minus 2, right? So what cancels out, guys? Good. The quantities x minus 2 cancel each other, right? Well, we just said on the last example then, if we set x minus 2 equal to 0, we get x equals 2, right? So we have a hole at x equals 2. But then this other factor in the denominator that didn't cancel out, that one's still going to generate a vertical asymptote then. So that's what you got to get straight on this. If it cancels out, that factor, it makes a hole. If that factor on the bottom in the denominator doesn't cancel out, then it makes a vertical asymptote. So that means we're going to take x plus 3 and set it equal to 0. And we're going to get x equals negative 3. And that's going to be our vertical asymptote. That's going to be at x equals negative 3. All right? And now look at what this function simplifies to. If everything canceled on the top up here, that leaves you with a 1, right? X minus 2 over x minus 2, that's a 1. So if everything canceled out on the top, the numerator is a 1, and the denominator is just this factor right here, x plus 3, because the x minus 2 factor canceled out. So we got 1 over x plus 3. Well, that's a way simpler function now. Do you guys see that? In fact, that's our first part of the lesson yesterday. Y equals 1 over x plus 3. that is a transformation of this graph. Remember we did this yesterday? Our basic graph was 1 over x, right? And we know that that 1 over x graph, that looks like, well, it's in quadrant number 1 right here, and it's in quadrant number 3 right here, right? Well, do you guys remember from yesterday then? What happens if I have that x value plus 3? Which way does it shift the graph? Up, down, left, or right? It's the x plus or minus a number. So is it a horizontal translation or a vertical translation? So which way is it going to shift? Up, down, left, or right? That is correct, Carter. It's going to go left 3. I like how you guys answer me by pointing your fingers and raising your fingers in this class. I don't think I've ever had a class do that before. So, yeah, so this transformation right here, that's a horizontal shift 3 to the left. So that is left 3. So that means all we got to do is take our basic graph right here, or our parent function, and shift that to the left 3. So remember yesterday I said take that point 0, 0 where those two asymptotes cross and just shift it 3 to the left. Well, that means it's going to take your vertical asymptote and shift it 3 to the left. So let's see if we can sketch this real quick. So let's see, maybe I need a little bit more room. So here's our sketch. Nope, I didn't want that color. So here's our sketch. We're going to shift our vertical asymptote 3 to the left. So we're going to go 1, 2, 3. Here's our vertical asymptote. Like that. And then from yesterday we learned then that, well, this graph would normally be like in quadrant 1, but in this case it's going to look like this. And then the other part of it would be in quadrant 3 over here, which would look like this. Kind of extend that out a little bit, like that. So there's our graph. But we can definitely see our vertical asymptote right here, right? It's at x equals negative 3. That is definitely negative 3 right here. Where's our hole at? I didn't put my hole in there yet. Where is it? Tells you right there. Where do we find the hole at, guys? Come on, jump in there. Let's wrap this up. This is the last problem, last question I got to ask you. It says right on the board, where's the hole at? Don't be shy. Don't sleep. Come on, somebody read it off. It's circled. Yeah, the hole is at x equals 2. So that means you got to go to 2. So 1, 2. And you got to come up here and hit the graph, and there's going to be a little hole right there. No, of course, that's too much, but... So there's going to be a little hole at x equals 2, so it's going to look like this. There's a hole, and it looks like that. Now again, you guys are kind of lucky on the test itself. It doesn't make you do the whole thing. It says find the holes, find the vertical asymptotes, find the horizontal asymptotes, find the zeros, where you don't have to actually do the whole thing, you know. But that's our graph. So your assignment is already on the board over here, so we're just going to add it on to yesterday's homework, all right? Same page. So it's still page 597. And we've got 26 to 31. All right, so let me stop my recording here. Now what I'm going to do with the rest of the time here real quick is I'm going to graph that last problem we just did. I'm going to graph it on the graphing calculator for you guys just real quick so I make sure you know how to do that. And again, you guys at home can try one of the calculator apps that I told you about in yesterday's video lesson to try to bring up these graphs and see what they actually look like and make sure you can